Holiday and Resnick, Chapter 24, Problem 32. A non-uniform linear charge distribution given by lambda equals bx, where b is a constant, is located along an x-axis from x equals 0 to x equals 0.2 meters. If b is 20 nanocoulombs meter square and v equals 0 at infinity, what is the electric potential at A, the origin B, the point Y equals 0.15 meters on the axis? Two locations, so A and B. Now this is what we have. We have a rod. And the total length is 0.20 meters. And this is 0. And we know that lambda, this is given to us, is equal to bx. And the value of b is given to us equals 20 nanocoulombs per meter square, and we want to calculate the potential. This rod is non-uniform. In other words, the density of the charge varies. So we take a little section of this rod, and that's dx, and a little charge dq. We'll start with lambda. Well, first, we'll write dv, that's what we're going to be looking for, is equal to dq, K times dq over R. So that's basically how we're going to build up our formula to solve for the voltage. So lambda is equal to Q over X. Usually they say L, but we're going to use X for the length of the rod. So Q, we'll solve for Q. Q is equal to lambda X. dQ is going to equal to lambda dx. So dV is going to equal to K. And dq is lambda dx. And our R, we're just integrating along this rod, and our R as any point X. As we go to 0.20. So for R, let's just say R. So I said Kx dx, that's how bad my lambda is. This is lambda. K lambda dx over x. R is equal to x. Now we go integral dv is equal the integral, and this is going from 0 to 0.20. That's the range or limit. Lambda dx over x. and this is you got K times that. So this is going to equal K. Lambda is a constant, and lambda is also equal to Bx. So let's put lambda as Bx. And we're going to have the integral dx over x 0 to 0.20. Now the x's, they cancel. That's what's nice about this. The x cancel. So we have V equals the voltage, K, constant, B is still out there as a constant, and it's given to us as 0 to 0.20 dx. And when we perform this integration here, we're going to have V is equal to K times B X 0 to 0.20. K is 8.99 times 10 to the 9 Newton meter square, Coulomb square, times, this is 20 nanocoulombs, so this is 20 times 10 to the minus 9 coulombs per meter square, times our limit at x, which is 0.20 meters. So we'll pause and I'll do the calculation. And that will come out to be 35.96 volts, which is 36 volts. That's part A. Part B, they want to know a point Y that's 0.15 meters above the origin. So let's draw our rod again. We're going to have a point, that's the Y, and so we do the same thing for us dq and dx, and we know this is Y, and this is R, and this whole bar length is X. We're still setting up V dV. It's equal to dq over 4 pi epsilon naught R. But this time R going to equal to the square root of x squared plus y squared. B is still bx, still equal lambda. So lambda equals q over x. So q is equal lambda x dq is equal to lambda dx. So dv going to equal, here's dq, lambda dx over 4 pi epsilon naught r and this will go to v equals, lambda is a constant and lambda is equal to bx. So the b 4 pi epsilon naught. I used k the last time, but this is the same thing, 4 pi epsilon naught integral x, that x came from the bx, dx over square root of x squared plus y squared. We're going to use a u sub to solve this integral. We're going to say u is equal to x squared plus y squared. We're going to solve for x squared here. We're just going to say x squared is equal to u minus y squared, and du is going to equal 2x dx, and du over 2x is equal to dx. Now, we write our formula integral down again. And since I have that 2x, I'm just going to say b over 4 pi epsilon naught integral x, that's that x there, and dx is du over 2x, so this x, they cancel. over the square root. Now this x squared here, I'm going to have to put this x squared equal u minus y squared for that value. So u minus y squared plus y squared. So that will cancel. And I'm left with v equals b over 4 pi epsilon naught du over 2 root of u. And this will go to b over 4 pi epsilon naught integral. We can take that du u to the minus 1/2 over 2. And this is going from 0 to 0.20 on x. That's going to be our limits. So v is equal to b. b is equal to b over 4 pi epsilon naught. That's u. Now when you to the minus 1/2 plus 1 2 times the 1/2 that comes down evaluate it from 0 to 0.20. Let's clean it up a little. This is a b over 4 pi epsilon naught. This u is the square root. We can put it back because it's just u to the 1/2. So that's the square root of x squared plus y squared. And these 2's cancel out. So I didn't need to put it up there, so I just put it up 1. 2 times 1/2 is just 1. Evaluate it from 0 to 0.20. This is going to equal, b is 20 times 10 to the minus 9 over 4 pi epsilon naught we'll put the 0.20 in here. That'll be 0.20 squared plus, there's y, which was 0.15. So we'll have 0.15 squared minus, we're going down here, and when we stick 0 in for x, we're going to have just a root of y squared, which is 0.15. And finally, 20 times 10 to the 9th over 4 pi epsilon naught square root 0.20 squared plus 0.15 squared minus 0.15. And we'll pause. When I calculated this, I got 17.98 volts, approximately 18 volts.